Let us try to deal with the center of mass of semicircular disk. When you consider the semicircular disk, so it contains like this. These are the coordinate axes x and y, and let us imagine that there is a disk like this. This particular disk contains a uniformly distributed mass over the entire system. So, if the system contains a uniform distribution of mass, then under this particular situation, the total mass of the disk M given by half of the original mass. That means total mass of the disk what we are imagining here in this particular plane is equal to half of the original mass. So original mass is computed by using the formula thickness of the disk into cross section area pi r square, we can write down, into, this is called what, thickness into area called as volume, into density of this particular material is nothing but rho. Like this we can prepare. No doubt that is this particular smallest elemental length like this. I'm just considering a small portion of the disk like this. This particular portion of disk, smallest elemental of portion we consider here. This particular disk contains the imaginary radius of small r, and the width of the radius is nothing but dr. And when you consider the smallest portional element, okay, this particular element contains a angular distribution of d theta at the center. Now the mass of the element what we considered is equals to rho into, we have to differentiate above equation, so rho into t into r into dr into d theta by right down. Here we are not considering full 180 degrees, smallest angle only we considered, therefore we got the value of dr here. Anyways, differentiation of r square is nothing but 2r into dr, we can write down, the 2 gets cancelled, r dr is the remaining values, rho and t are constant quantities in the problem. So therefore we got the value of mass of this particular element. Now further, if you consider this is at an angle of theta degrees, and this particular portion is at a distance of small x, and a particular portion is at a height of what, y, then the x coordinate, no doubt x coordinate is equal to, you can write down as r cos theta in the problem, and y coordinate as you can write down as r sin theta in this particular case. No doubt that is this particular system contains a center of mass for the x coordinate is 0, because there is some uniform distribution over here and here. No doubt that is center of mass exists only along the y axis. So therefore our job or our aim is to find out only YCM in the problem. Let us find out y coordinate of center of mass of the system. Let us see. We know that the formula y coordinate of center of mass is given by YCM is equal to integration of y dm divided by integration of dm. This is the formula what we can use in the previous case also. Now we are using the same formula for this particular case. This is given by integration of, the value of y in the problem is nothing but, already we got the value of what, r sin theta, r sin theta, and the mass contains a formula for rho tr dr into d theta. This is the formula for dm. Therefore rho tr dr into d theta we can write down. Again here angle is there, therefore we have to take double integration in the given formula. Double integration, angle running from 0 to pi, distance running from 0 to r, divided by dm. So same to same case, integration of, you can add on as rho t r dr into d theta, running from limits here 0 to r for radius and 0 to pi for angle we have to take in this particular question. Now no doubt that is in the given case thickness and density of material is constant, therefore rho t and as well as rho t, we can cancel the two terms in the given equation. Now further we can prepare like this. Substitute the value of what remaining values. So integral 0 to pi of 0 to r radius r into r square dr. Remaining angle will be sine theta into d theta whole divided by 0 to pi of, you can write down as what, here r dr will be there, therefore integration 0 to r dr, and again nothing will be there, therefore you can write down as d theta at the outside of the system. Now the final step will be like this. R square integration is r cube by 3, therefore upon substituting final results r cube by 3 we can write down, because limits are 0 to r given. Now sin theta integration will give you minus cos theta. This will be in the integral limits of 0 to pi whole divided by denominator. So in the denominator we have only r dr is there. Upon doing integration we have r square by 2. Upon substitution of limits we have r square by 2 of upon substituting integration 0 to pi d theta means what, you can write down as theta only, 0 to pi we can write down, and hence this particular result will give you r square r cube gets cancelled. We have the resultant will be r, denominator of denominator goes to numerator, therefore 2r by 3 into, here it is pi, of course the value of minus cos theta over 0 to pi, this value will be 2, therefore the answer will be ycom is equal to, you can write down as what, 4r by 3 pi, we can write down like this. Therefore our answer for the question is given by 0 comma 4r by 3 pi. This is the position of the center of mass of our particular target. Thank you. Still, those who did not subscribe my channel, please subscribe for further updates, and try to share my channel to the students, those who need for the physics. Thank you very much.